Hi, my name is Ho-Chan Lee, and I'm a PhD student at UT Austin. And this work is about the comparative study of metrics and graph approach for graph analytic applications. And this work was done by a number of folks from UT Austin and Intel Corporation. And first, let me differentiate the representations of those two approaches. They have a different views for graph analytic problems. First, graph approaches represent your graph with vertices and edges. Metrics approaches use an adjacency matrix for representing a graph. In graph approaches, each node could have its own data. Metrics approaches use a sparse vector for storing them. Graph approaches use a worklist to maintain the active vertices. In metrics approaches, we use a sparse vector for that. We can directly apply operators to the active vertices in graph approaches. In metrics approaches, we exploit metrics operations like matrix multiplications. And there are many stable systems for those two approaches. However, the comparative study between these two approaches has not been done actively. So in this work, we firstly attempt to compare these two approaches in terms of expressiveness and performances. And this is our contribution. First, we show that GraphBLAS Galois is 5x faster than the matrix-based SuiteSparse on 56 cores on average. And there were three differences of runtime system, algorithm, and API. So in order to focus on the API differences, we firstly remove the runtime system differences by implementing matrix-based GraphBLAS on the Galois runtime. And in this case, Galois showed 4x faster performances than the GraphBLAS on 56 cores on average. And then we tried to remove the algorithmic differences. In order to do that, we improved algorithms expressed in GraphBLAS API as much as possible. Finally, we identified and quantified inherent GraphBLAS API limitations, which are irrespective of architectures. And this table is showing the 4 factors of the matrix API limitations. First one is that the matrix API requires a frequent materialization. And due to this, for triangle count on UK07, the GraphBLAS implementation showed 3x slower performances than the Lone Star. Second, matrix API is intrinsic to the work operations. Due to this, for connected component on our graph, GraphBLAS showed 3x slower performances than the Lone Star. And thirdly, the matrix API also intrinsic to the round-based execution. And due to this, for SSSP on eukarya, the GraphBLAS implementation showed 300x slower performances than the Lone Star. And lastly, to represent the composite operations, the matrix API requires multiple loops. And due to this, for BFS on road USA, the GraphBLAS showed 5x slower performances than the Lone Star. And our paper explained the detailed analysis with sufficient experimental result. And thank you for listening to this talk.